Fractional exponents are just another way to express a root. So if you have the square root of 2, you can write it two ways. You could either write it as this little bracket called a radical with a 2 inside of it, or you can write it as 2 to the 1/2 power. So these unit fractions with a 1 in the numerator, 1/2, 1/3, and so on, can be used to represent the different kinds of roots. A square root is represented by that base raised to the 1/2 power. The cube root of 2 would be 2 to the 1/3 power. The fourth root of 2 would be 2 to the 1/4 power, and so on. The rules for fractional exponents are exactly the same as they are for any other exponents. When you have like bases and you're multiplying them, you can add the exponents. So x to the 5/3 times x to the 8/3 is x to the 5/3 plus 8/3. If you have a power raised to another power, you multiply the exponents. So x to the 5/3 raised to the 8/3 is equal to x to the 5/3 times 8/3, which is 40/9. All right, so same rules here. If you have 4 raised to the negative 1/2 power, that means 1 over 4 to the positive 1/2 power. And that means 1 over the square root of 4. 4 to the 1/2 means square root of 4. And that is just 1 over 2. Over here, you've got negative 27 raised to the negative 1/3 power. So this is going to be the same thing as 1 over negative 27 to the positive 1/3 power. You're changing the sign on the exponent. Now, this negative sign right here, since we don't have any parentheses, this negative sign will not be affected by the exponent, and I can put that negative either in front of the fraction or in the numerator. So I'm just going to put it in the numerator so I don't get confused by it. And then I've got 27 to the 1/3 power, which means it means the cube root of 27. And the cube root of 27 is just the number you would multiply by itself 3 times to get 27. So that would be 3 times 3 times 3 gives us 27. So this is negative 1/3. When we have an exponent that has a numerator that is not 1, the numerator of that fraction tells me what power I should raise that to. So if we wanted to simplify 16 to the 3/2, what that means is, if I look at that denominator of that fraction, it's telling me to take the square root of 16, and then numerator is telling me raise that to the 3rd power. So denominator of the exponent tells me take the square root, because that's a 2. The numerator, the 3, tells me to raise what I just did to the 3rd power. So the square root of 16 is just 4, and then 4 cubed is 4 times 4 times 4, which is 64. Same thing going on over here. I've got negative 8 to the negative 2/3, which is going to be negative, and I'm going to leave that negative in the numerator, negative 1 over 8 to the positive 2/3. So I've got negative 1 over the cube root of 8, and I'm going to square that. So negative 1 over 2 is the cube root of 8, so 2 squared, negative 1 over 4. A situation where we would want to use fractional exponents would be a expression like this, where we have a square root inside of a cube root. It's a little bit complicated, so we want to make this look more uniform and more simple. And so we're going to just change all the radicals to fractional exponents and get like bases on everything. So we're going to, first of all, write everything as a power of 3, because we know 27 can be written as a power of 3, and we already have a 3, so we just want to get everything to have the same base. We will write this as the cube root of 3 cubed, because that's what 27 is, and then we have the square root of 3. Now that we have the bases all the same, we're going to change the outside radical to a fractional exponent. So all the stuff in this problem, all the numbers are under this giant cube root sign. And so we want to change that all to raising 27 square root of 3 to the 1/3 power. So instead of using the radical with the little 3 in front of it, we're going to use the raising it to the 1/3 power. So the stuff under the radical, 3 cubed, square root of 3, is raised to the 1/3 power. So I'm just changing that cube root to a fractional exponent. It's just another way to write cube root. So now I'm going to rewrite that square root also as 3 to the 1/2. So now I just have all fractional exponents, and I can use my rules for exponents to simplify this completely. So I've got 3 cubed times 3 to the 1/2, all raised to the 1/3. And so the first thing I'm going to do is multiply the exponents by the power that I'm raising both of these numbers to, 1/3. So I will have 3 to the 3 times 1/3, and I'll have 3 to the 1/2 times 1/3. So when you raise a power to another power, you multiply the exponents. So this first 3 is now 3 to the first power, and the second one is 3 to the 1/6 power. Right? When I have like bases, which I do here, both bases are 3, I can add the exponents. Now be careful, don't multiply 3 times 3 and get 9. That's not how the rule works. Remember, if I have a to the first times a to the 1/6, that is equal to a to the 1 plus 1/6. That's the rule. So even though this is a 3, because this is these are 3s, it makes you want to multiply them. Whereas if you just see a letter, you know you don't do that. And that's the rule. You don't do that. So say you have 3 squared times 3 raised to the second power. You're going to use that power rule to multiply the exponents. So 3 to the 2 times 3 squared. And that's going to be 3 to the 4th times 3 squared. That does not equal 9 to the 6th power. It equals 3 to the 6th power. Okay, because 3 to the 4th is 3 times 3 times 3 times 3. And 3 squared is 3 times 3. So that's 6 of them. 3 to the 6th power. Okay, so don't get excited and do that. It's just 3 to the 1 plus 1/6. And that is 3 to the 7/6. All right, here's another one. Now, all the things we have are under a 6th root. So first of all, I'm going to write everything with a base of 2. So I'll write this as the 6th root of 2 squared. That's what 4 is. And then the square root of 2. I want all my bases to be the same, because if all my bases are the same, I'll be able to add exponents and all those things. So now I'm going to change that 6th root to a fractional exponent. I'll change it to 2 squared times the square root of 2 raised to the 1/6 power. It's the same thing, means the same thing. And then I'll go ahead and change that square root to a 1/2 power. Square root of 2 is 2 to the 1/2. And now I'm going to raise a power to another power. I'm raising this 2 squared times 2 to the 1/2. I'm raising it to the 1/6 power so I can multiply those exponents. So I'll have 2 to the 2/6 times 2 to the 1/12. I'm multiplying each exponent by 1/6. So that's 2 to the 1/3 times 2 to the 1/12. And again, we have like bases, both are 2. Our answer is going to be 2 raised to the 1/3 plus 1/12. When you have like bases, you add the exponents. You don't multiply the bases to get 4. That's not the rule. The rule is add the exponents. Leave the base alone. It's fine the way it is. So 1/3 plus 1/12 is 4/12 plus 1/12 is 5/12. 2 to the 5/12.